Hello. Yeah, my name's Phil Watts. I'm a DevOps architect. It says artificer because I hate my title. And I work at a company called REAN Cloud. We're an SI partner with HashiCorp. And I work with a lot of Packer and Consul and Atlas and Terraform and pretty much the whole stack. But recently got interested in container management and in particular working with Nomad. So sort of where I start is business needs and business desires really have cared about abstraction away from operational issues. Once virtualization became a concept, people no longer were interested in finding out that the rack's power went out or there was a power outage in a particular building. So we left to the point of saying, virtualization grows and eventually moved into cloud infrastructure. What we are left with is an idea where the business expectation is sort of some guy in IT performs some sort of fancy magic and your application ends up running on anything. There's the phrase flexing between the clouds has come up in conversations throughout my career so many times. And I've always had the same look of disappointment where I want to say, like, it's not really that easy. It's, you can't just shoot things around and everything will work. But interestingly, when I was at HashiConf in Portland last year and Nomad was announced, I started to think, if you take containers and you take a scheduler and you take the power of service discovery, particularly interesting things like the network tomography inside of Consul, why can't I just point it at anything? Why not? So I started down this sort of adventure of seeing if I could tie this service experience to everything. It helps in the arguments against vendor lock-in, which we probably have all heard too many times. And it also sort of allows you the flexibility to deal with workloads where the workloads aren't necessarily business equivalent as far as their value. So I started off with the idea and thought, how do I determine if I've created something right? Call it a bad habit from test-driven development, but everything starts that way for me. So I wanted the resources to be available sort of regardless of what provider they would be running it on, what provider would be available. Similar, another favorite question of mine is, what happens if AWS goes down entirely? Or what happens if the entire US East region goes down? My response usually is something like, I expect there was a volcano, I am probably on fire, I'm not sure what you want me to do, but this sort of idea allowed us to say, well, what if I can say any of these cloud providers? Another interesting point that came up in our work was companies that have batch workloads, like large batch workloads, tons of things, more data than time, or more data than there is time and money, more importantly. An example I sort of go back to with the batch job scenario in Nomad is if any of you remember running like SETI at home or folding at home, two programs where you could just let something run on your computer and it would get a tiny snippet of radiogram data from space, and it would let your computer look to see if aliens were trying to speak to us. But it's an example of a distributed batch job where there's a near infinite amount of data. There's compute power that could do it, but nobody's going to pay for it, so you can volunteer that time. Businesses sometimes have problems that are very much like that, where I have lots of data I could analyze. It would be great if it was all done. Nobody is going to approve you buying additional hardware. Where do you fit it in? And the last thing I was concerned about, because my company does a lot of work with regulated industries, was I still want to be able to segregate workloads sometimes. There are still compliance requirements that, for varying degrees, can allow some cohabitation of workloads. and have various degrees of isolation. Not everything has to be in its own very specific own box in order to be in line with compliance. So I came up with some fun pictures of tooling that goes into it, and my favorite would be, there's a slide later about widely distributed ad hoc tasks. The picture there is the shell shock vulnerability. Just something that comes up and you're like, oh God, what do? We have to run a command on every system we have. There's answers for that in Nomad. So what I did when I set out to build this environment is I used a different set of tools. I wanted to call this slide my favorite toys, but unfortunately I used Azure, and that doesn't really qualify anymore. So obviously Packer to help build the container images themselves, Terraform to build infrastructure across multiple cloud providers, Consul handling service discovery, Nomad handling scheduling. And I primarily use Docker as the driver in the work. Now, I get to the hard part, and this is my least favorite thing about being a technologist. We are awful at naming things. We take a word, and it's a perfectly fine word, and then we come up with 15 definitions for it, and they all mean something different, and all of a sudden I say the word environment, and you don't know what the hell I'm talking about anymore. Like, is it an environment variable? Is it a data center somewhere? Is it a release tier? Are you using Puppet and it happens to be a set of code? But inside of Nomad, at least, HashiCorp was very kind in the way that they are consistent with the language used in Consul as well. So a region is an isolation boundary. The concept of regions can be split up to any granularity. There's no hard and fast rule about what you have to make a region. A data center would be defined as a low latency network, high bandwidth, private. This turns out to be often like a region in AWS is often referred to as possibly a single data center in Consul. And the resources is a concern inside of Consul. Basically, that's what the nodes provide. Be it disk, memory, IOPS, any processing capability. So the models that you could potentially be looking at in this situation is a common pattern I've seen is to define regions off of global locations or off of like a continent. I'll have a US region, and then I'll have a Europe region. And that means that jobs can only run if they're scheduled for the US in the US. As has been mentioned before, there is forwarding if you interconnect regions, meaning if somebody in Europe requests a job that needs to run in the US, that job will just be sent over to the US to run. These things tie in, and then you get down to the level of data centers. So the common example here is matching the Consul model where you use an AWS region, you could use a Google Compute region, or you could use a set of locations inside of Azure or a single location. Now this can actually get really fine-grained. I've seen a few situations in which the definition of a data center, which isn't necessarily the best way to go about it, could be as small as a placement group inside of AWS. And their region could be a single availability zone. There's nothing about the code that prevents you from constricting things that far. The reality, the real goal, is to go the opposite direction and say, my region is all my Consul servers, all my data resources across the entire world. And there's mechanisms by which you can control where they run. So we'll give things the availability for jobs to run anywhere, because there are some jobs it doesn't matter where it runs. It doesn't matter that you have an app that watermarks an image. It doesn't matter if that image came in Australia versus in the Netherlands. Just where's the compute to run the process? So that's sort of a longer term goal and requires a little bit forward thinking to get to. So the way this works, and this is obviously a picture from the documentation, is Consul is in a cluster. However, one server is dedicated as the leader. The leader server in this situation is basically a benevolent dictator for life. All of the servers will provide evaluations. They will attempt to make allocation suggestions. But as far as what actually will happen, the leader is always authoritative. So there's a forwarding of information there. The piece about, it's a benevolent dictator for life is, well, when it dies, RAF just goes back into moving everything into a candidate state, and one of the other servers will then become the leader. So you will sort of remain fully active, fully functional in the case of a failure. So here I decided there's an interesting way of looking at things in Nomad. Looking at, sort of 3 sets of displaying resources, and really they're all describing the same thing. I would find people often wanting to break apart where their Nomad systems existed. I have clients in these 3 availability zones, and they have a Consul client and a Nomad server, or a Consul server and a Nomad server running. However, up in the Azure block, I'm just saying I have a Nomad server, a Consul server, and I have resources. Down in the bottom, and this is sort of a preview of a slide later that talks about bin packing, we have a more complicated picture in which we're saying we're going to think about the individual systems inside of this Google Compute instance. Nomad sees all of them like the top picture. It just sees, I have a data center. The data center has capacity. It has functional ability to do work. And that's really sort of the goal in Nomad, is abstracting your resources, your capability to do work from the actual work that you're going to do. So the next set of defining words that has to come in is on the job side, or on the task side. So again, HashiCorp favors the declarative state style. So a task will describe a piece of work that they want done. Now, it goes into the 3 types of jobs, batch, system, and service. So this is just a place where you declare, I would really like my Apache server to be running always, or I would like these batch jobs to run under given conditions. Constraints are the mechanism by which you provide rules to tell Nomad when it can't run a job in a particular place. This can be really useful for applying compliance, and also if you have functional needs that are tied to these different cloud providers. We're not going to pretend that they're all equivalent. Some have fancy special features that others don't have. If you have an app that requires tight coupling with one of those features, you may add a constraint that says it has to run in this particular region, this particular data center. Evaluations are basically queued requests to compare the present state versus what's actually running in the region. And they're caused by state change events. So new jobs being scheduled, jobs being finished, jobs being added, failures of nodes. All these things sort of cause Nomad to realize that its desired state and present state are not sort of synced up with where they want to be. So Nomad will then go back through the process of reconciling that. So the sort of types of jobs, the first one is, and this is sort of your most common job type that when you think of running a system or a service for your company, is something you want long running. I want my Apache servers up, I want my app servers up, I want database up, my front end user experience needs to function. And the favoring inside of the logic for this job type is heavily weighted towards providing quality of service. So it's similar to an idea of having auto-scaling or distribution just for this particular type of job. So obviously the example of keeping those front-end services alive. The next type of job is batch jobs. So batch jobs are, again, my lovely example of SETI. I have a bunch of things to do, or watermarked images. My favorite actual experience with this job type is I worked with a company who took CAT scan images of the heart. Okay? So these images taken externally of how your heart is beating at a very high frame rate, and they took those images, broke them into pieces, and then did linear algebra to follow the rippling of vessels around your heart. They used that to determine the amount of blood flowing around the heart, to then say, hey, maybe we don't need to give this guy an angiogram to find out if he has a blocked artery. We can see it based off of how the vein is behaving. Okay? This is a heavy computational task. It was comparing images with linear algebra. It was tied to a single core, but it was a perfect use case to split up into a containerized situation where you lock a small bit of data into a single thread of processing and say, go do this chunk, and then send it off back into the queue of finished data. So those batch jobs also had priority associated with them. Sometimes they had data that they were, they had a doctor actively using the service, and they wanted results to help treat a patient. In other situations, it was study data. The study data could be added as a job queue with a lower priority. And it basically means when Nomad does evaluation and determines an allocation, it's not going to schedule the study junk data, things I'd like to have done. It's going to say, I really need to do a particular batch job instead. Then finally, there's a unique job type called system jobs. System jobs are things that will run over entire systems or over all your nodes, or you can constrain that to be task or node groups. But it's a unique type of job in which you want to distribute something everywhere. It can be very useful at present to do things like ensuring that you have a container running a console agent that's also on the system, or using a log shipping coprocess. And both of those examples have been sort of invalidated by Mitchell like 2 hours ago when he said they're going to make them core features and it's just going to do that magically now, which will be great. So we follow through on that, and we get to this really lovely chart that explains how Nomad makes decisions. So what is it going to do? A job event happens in the top layer. Evaluations are created to determine the parameters and likelihood of the job. It's passed to a broker, which happens to be the leader. The leader ensures at least once delivery, which is queue language for probably sent it a bunch of times, but it really, really got received, as opposed to the alternative send once delivery, which is it went out, who knows where it went. So this is a way to ensure sort of consistency in the behavior, that these changes will be evaluated and your scheduled tasks won't be lost. The work that you've requested will be done. The scheduling is submitted into an allocation plan. The allocation plan is sort of it's a single systems attempt to say, I have decided that I will arrange all the jobs that I'm aware of onto this set of systems. It's very much like the plan option that Mitchell mentioned earlier, but these plans are compared against one another. And it's the leader, again, that evaluates the plans and says, out of all of these, your decision was the best, or your decision is invalid for a reason that you were unaware of. So That all happens, and it finally turns out to be allocations. Allocations are the messages, sort of the actions sent out to the Nomad systems, what they're going to do, what they'll start. So when those allocations are happening, or sort of the result of this process is kind of an interesting, it's called bin packing. It's based off the idea of I have many different boxes, and I want to pack them all in the same thing. Tetris for workloads, I guess. This picture is meant to be like a rough area graph in which you think of the width of an object as being the amount of memory it may require, and the height of an object as being the amount of CPU it may require. These are three separate nodes that, by comparing the fact that they have different height and width, they have different resources available on them. And it's just an attempt to say that Nomad will attempt to place things in the most efficient order. Now, reality most likely means there's not going to be 100% perfect utilization on the system. You can also explicitly set thresholds to restrict the amount of CPU utilization you have to 60%, something like that. But sort of the more difficult piece of drawing up this visualization and letting you know that Nomad is defining sort of dimensions for your work and deciding where they may best fit is that this is a two-dimensional area map. The actual calculation may be a five-dimensional consideration, and I can't draw that picture, but it figures it out. So another sort of valuable tool inside of this process is related around task groups. So you may group tasks together if they are either more tightly coupled or require exceptional low latency between them, things that must run as groups, sets of microservices that need to all be running on the same system in order to provide a consistent service. It's another sort of example of an interesting use case or sort of valid thing that you can do to control sort of the model of workflow that you're creating. Then I move on to, constraints as an idea is a way of saying that just because something can be scheduled doesn't mean it should. The constraints are the way that you can determine whether or not something is applicable to run on a given node. In the multi-cloud world, you usually end up having to cook your work down to a least common denominator, which might just be I reliably can have an object store, a system with local disks, and some networking, and that's it. But you want your app to utilize something a little more interesting. You want to have local access to a Lambda function. You want, I think, GPU, it's actually on the next slide as an example, but there are things that you may decide that you want to constrain your system based off what it should do. This can get down to the level of defining data centers or defining specific nodes. This can be valuable in compliance requirements that requires dedicated tenancy. You can still use the same concept of a scheduler to set the work and reliably always have it schedule in the same box. So in this example, I'm sort of looking at the idea of adding in metadata. So there's a metadata key that is sort of free form in the way that you set it. In this case, I'm saying I need to run in a PCI DSS compliant environment. There's a set of rules and restrictions that define what that means. And from a compliance perspective, you would be required to prove that all of those things are there, particular auditing, particular levels of security. But you can mark inside of Consul that a set of nodes passes that test and says, I am PCI compliant. Then any job that is constrained to run in a place where it requires that unique metadata key, you can call directly. This is a way that you can ensure I have PCI compliant systems. They must run here. you can get that to actually happen. Another case I've seen this used in kind of frequently is healthcare data in the EU, needing to stay in the EU specifically. So there'll be situations where a global health company will be aggregating a lot of data to a primary data center, and then they also happen to have a smaller data center in Frankfurt, because that's where there was an AWS node, and they didn't break any laws by keeping it there. So the next thing to sort of acknowledge is, when we look at these different platforms, they are different. We're not getting perfectly equal things, and sometimes you need to make acknowledgments of that. An example was, float GPU processing is available on AWS. It's not available in Azure or Google Compute. If you absolutely need that and you still want to schedule your job in a single place, you can do that. You provide a constraint and you inform your system that this is a requirement that I have, and I would like to set it to sort of pass this value and function in a consistent way. Now comes the scary one. This is HashiCorp's way of the Are You Sure box. It's very Unix, Linuxy in its world. They have some features that they just leave disabled by default, and you have to go in and tell it explicitly, no, it's cool, you can run that. If you use Atlas, the Terraform destroy model requires you to put in an environment variable specifically to be able to run destroy tasks. So of the drivers, you have Docker, obviously, QEMU for VMs, JVMs are supported, isolated execute tasks, and then unisolated execute tasks. Now these unisolated execute tasks, when run as system jobs, are basically saying, I will run a command, it will have escalated privileges, potentially, it will run absolutely everywhere, and it will do whatever it is that you tell me to do, okay? I referred to it as, it's Chekhov's gun. They put it there, someone's gonna use it. Like, someone will find a way. The danger is not using it all the time. You have to think about this as, this is my emergency, this is my, I can save the day. But, if you start using unconstrained task drivers inside of a scheduler, you kind of have stopped using the scheduler in a lot of ways. So it's nice that they put it in there. It's nice that they disabled it by default. It's just important to acknowledge that you should be making a second consideration before actually using it. So my favorite author is Robert Heinlein. I referred to a quote that says, it's a deep human instinct to either make everything in the world forbidden or compulsory. So here you have a thing, I'm telling you it's forbidden. Don't go out and make it compulsory. Don't run your entire infrastructure off of these unconstrained tasks. So the end result of this entire talk, and actually the most disappointing part of doing the work for this talk, was that Nomad just did this. It just worked. I had thought originally that this may take some effort. It turns out that there's a little effort involved if you want to do things like secure networking by connecting multiple cloud providers. There's a little bit of effort involved if you have other requirements that you need to maintain across different systems because their capabilities are different. But Nomad itself communicates in such a way that to Nomad, the resources are just resources. The clients are just in an area. The jobs are just scheduled based off of a sane allocation of where they should go. And here you have the example of we're back to our IT guy, and he's still expected to do magic. But what he's doing is small, simple changes. He's deciding this one job needs to run in one particular manner. And as that happens over and over again, as your business expands resources or as you put more time and investment into your scheduler, Nomad maintains that collective intelligence and builds a system that is elegant and complex without needing you to know how elegant and complex it was going to be when it started. Okay, so in the picture, I'm looking at it and saying, well, I might have log aggregators, I might have monitoring tied in, I can have some vertical requiring resources, I might have some tiny batch jobs, I might have EMR tasks, I may have all these things. If I had to decide how I was going to split this workload, it may be very difficult, it may be very time-consuming to figure out how I can most efficiently do this. But the experience is that if I'm that Lego man, I did not describe that whole thing one time. I created change events. I allocated jobs. The jobs had conditions to continue to run. Nomad re-architected, shifted things around, found the best solution. And it continues to find the best solution. And it doesn't care if it's an AWS resource or an Azure resource or Google Compute. It doesn't care if it's internal data center or internal cloud. It allows you to create magic by better tooling. So this is sort of the same end result. These disparate things are creating a wonderful and sort of elegant distribution of tasks, and it's all managed through sort of a single pane. And as they continue to develop Nomad, integrate it better with service discovery, so all these things can find each other. That's not even a concern. You can add in further knowledge into what you're doing. You can decide that you want to evaluate cost of spot instances for your low priority batch jobs, and then put in a constraint against a provider that will give you the cheapest instance to run your junk, you're able to do all of these flexible things. And what surprised me most is that Nomad just did it. I had more trouble getting the Azure RM Terraform provider to work properly than I did getting Nomad to just traverse globally distributed cross-platform networks at a simple level. So that's sort of my presentation. I have minutes for questions. So if anybody would like to ask anything specific. I also do have all of the code that built the environment that tested this available to me. I didn't add it into the slides because usually you can't consume it that quickly, but if anybody wants to look at anything particular, they can just come up and find me afterwards. But if there are any questions, feel free to ask now.
Phil? Thank you, Phil.
Thanks.